Hi, everyone. This is Aaron Larson, Executive Editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Harsh Shah. He's the Vice President of Sales and Business Development with Mitsubishi Power Aero. Harsh, I'm glad to have you on the show today. Please tell a little bit about yourself and what you do with Mitsubishi Power Aero.
Good morning, Aaron, and thank you for having me. I run sales and business development for our global Mitsubishi Aero business. We provide aero-derivative gas turbine solutions that provide flexibility, speed, fast-track solutions for customers worldwide.
I know Mitsubishi Power Aero is kind of a rebranding. Your company used to be called PW Power Systems, and that changed, I believe, on April 1st. Can you explain some of the reasoning behind the rebranding and how you feel that benefits customers going forward?
Yeah, absolutely. The rebrand it's part of a larger effort to create and leverage synergies across the global Mitsubishi Power and the Mitsubishi Heavy Industry teams. For Mitsubishi Power Aero, we have been committed to providing aero-derivative-based power generation solutions across the globe. Having the brands merge together with the Mitsubishi brand basically, captures our commitment to continue leading the provider of aero-derivative power solutions. Our core groups, whether it's engineering, supply chain, operations, R&D, we have been collaborating very closely with the Mitsubishi Power groups. So this change in brand and the alignment with Mitsubishi Power is going to help us serve our customers even better.
From what I understand, Mitsubishi Power Aero supplies kind of a fast-tracked, on-demand power solutions for producers, which could include utilities and industrial customers and even oil and gas customers around the world. What is the advantage, and is there a lot of demand for these aero-derivative options?
There is. If you look at the high-level goal for the industry in terms of decarbonization, grid resilience, resource adequacy, and affordability, the aero-derivatives fits perfectly in all those categories. We provide solutions that generate power from 30 megawatt to 140 megawatt, and we see a very strong demand for these products across the globe, everywhere, in developing nations, whether it's industrial, the utilities, independent power producers, and even captive power producers. And the main reason for this demand is when customers are looking for fast-track power solutions where you don't have to wait, months and years from the time you conclude a contract discussion to the time the power can go online. So when the need is, time is an important factor, this aero-derivative solutions is very important. And going a little bit further on the time aspect, it's not just the time that we would deliver, install, and commission the power plant, but also the time in terms of flexibility and responsiveness of the solution itself when it is working, either in a grid environment or independent in a grid environment. So if you have a requirement where from the start of, pushing the button to start the unit that could be in a completely cold condition to the time it goes to full power, our aero-derivatives offers a very unique value proposition to our customers, whereby we would be fully up and running in less than 10 minutes. And we're pushing that envelope, to lower and lower times, 5 minutes and such. So when you're looking for fast-track solution, when you're looking for the quick response solutions, and then the last aspect that I would add is flexibility. And this is flexibility from different perspectives. You could have flexibility in terms of the ramp rates, how quickly you can go up and down. And this is especially important as across the globe you have more and more renewables on the grid. You need solutions that can cover when the sun is covered or the wind power drops off. So the ramp up, ramp down, and fast responsiveness gives the very much required flexibility. In addition to that, we get flexibility because of multi-fuel capability, whether you are using gas or liquid fuel. You also have flexibility for dual frequency in 50 or 60 hertz. And then the last aspect of flexibility that I would touch is very high power density. Unless you are on a volcanic island, which is kind of creating new land, we are living on a fixed piece of land, and optimal use of land is very important. And the high power density of our solutions is creating a lot of demand.
Can you give any examples of where some of these gas turbines may have been recently selected and installed and constructed, and what benefits specifically the customer was able to achieve?
Yeah, absolutely. I would highlight one of the most recent example. Earlier this year, we started working with CFE in Mexico for a summer demand in the Mexicali, Baja California region. So while they have enough capacity to meet most of their demand, in the summer months, you run into certain shortfalls. So if you are relying on that electricity and you'll be out of power in really, really hot climate, it's obviously not fun as an individual. And if you're an industry, you do not want to have any business disruptions. So the customer in that case was looking for a fast-track solution. We started talking, literally in January this year. From the time we signed the contract in just about 110 days, we had 150 megawatts of power installed, commissioned, and online. So we supplied 5 mobile pack units. These are trailer-mounted, very mobile, very compact units. Don't require any site preparation in terms of, you don't need a concrete, foundation. Minimal work required at the site. And as I said, from the time we signed the contract, within 110 days, we had power up and running. So we supplied 5 mobile packs to meet this summer demand. So starting June 1, they had all the power that they required. So that's a great example. In addition, we had similar situations in Puerto Rico, where we supplied these mobile, compact, efficient facilities for power generation. And the benefit again is the rapidly deployable off-grid solution is really helping this Caribbean island where, as you would know, you have prolonged power outages from the hurricanes and very unstable power supply from the renewable energy. All of that created issue, and then our solution really helped them get 90 megawatts of power on the island.
Yeah, I can see how that would be really important and beneficial that you can do this very quickly. Do you typically see, for example, the one in Mexico, would they use that for a certain length of time usually, or can it, while they're building maybe a more permanent facility, or is this something that you think will be there and be used for years to come?
That's a great question. And, for Mexico, they certainly wanted to have a mobile solution. So as their demand shifts, they will move the units to a different location. That was actually a very essential part of our discussions with them, where the units are there for this summer. We will be delivering a 6th unit also next year, which will be placed in a different location. And so these units also would relocate as their long-term generations come online. We had similar situation in another place in the world, in Algeria, where the country was planning to install, fairly large-scale equipment, but that large-scale equipment was coming at a significantly longer time than what the citizens could afford. So they went ahead and over a period of few years, through different arrangements and contracts, they installed, bought 54 of these units. And again, if you add it all up and, roughly 1 gigawatt, basically, the reason for such high requirement or demand for the mobile power is as you wait for your permanent generation that could take anywhere from 2 to 5 years, the mobile solution can give you power within weeks and months, and you can very easily relocate it when your demand or the supply shifts. Case in point is again Algeria, where they have relocated the mobile packs to a different location once again the supply-demand equation changed.
And you've obviously mentioned that you have these all over the world. Are there certain regions that you think are more prone to this solution, that find aero-derivatives more desirable, for example? And are there certain industries that might use these more prevalently than others? Can you answer either of those questions?
We see the demand for these in developed as well as developing nations. We have seen, I've talked about the Puerto Rico, Mexico, Algeria example, driven by the fast track requirement. But, it's beyond that. If you take the unfortunate events in Japan in March of 2011, when the earthquake, tsunami caused significant issues, the mobile pack solution was a key. Mobile pack was part of this overall solution to get power up and running very quickly. So even when you have emergency situations like this, you cannot really wait for a large power plant to come up. The mobile pack are designed with black start capability, so effectively you can be independent of the grid, and you can still start producing power in that mini grid or microgrid, or you can actually help restore the grid operations. The other places we have seen demand recently that I would like to talk maybe just a little bit about is, as we have seen in the U.S. oil and gas industry, where in 2018 we started working, and then the customer was very, very pleased with the mobile pack solution because in their environment, they really have this hydraulic fracturing operations across Texas, Pennsylvania, and other parts of the U.S., where they have this electric fleet to do the pumping, and they want to go to a particular site, work at that site for a few days, maybe a couple of weeks, and then you can be done there. So in situations like that, you don't have access to a grid, you are in a very remote location, you certainly don't have, you don't want to set up a permanent power plant. So in those cases, you would take a unit like this, use it for, a few days, weeks as you require, and as I would like to say, pack it up and take it to the next location. Very effective in terms of time and resources it would take them.
Yeah, it sounds like a pretty efficient process with the mobile pack, getting it to the site where it's needed and kind of setting it up in a fairly quick and efficient way. The one thing that I could see being a potential problem would be the infrastructure. Do you ever have concerns with that, where maybe getting the wires where they need to go takes more time than getting the machine where it needs to be?
Yes, I'm glad you brought it up, and I should have said it earlier, maybe elaborated a little bit earlier. Actually, it's quite the opposite. It's actually a benefit where you don't need a whole lot of infrastructure. You really need, your fuel, water supply, and then you need a way to evacuate power. So if you are connected into a system like that, then you are good to go. Basically, going back to the example for the oil and gas, it was really interesting that they were using, diesel fleet before. So you're doing hydraulic fracturing in this remote locations, and the customer was using, diesel fleet. So basically a power generation unit that would take diesel fuel and produce power to operate the pumps and all that. Basically, with this electric fleet, our customer was able to use just local natural gas, which is coming from the field, and they could set up these, operations such that you completely eliminate the diesel fleet requirement. So, for a typical operation, they would require an estimated of 25 diesel trucks, and now that whole requirement is gone. You don't need that. So you eliminate a lot of fire hazards, you eliminate the spills, you eliminate a lot of noise issues. Going from diesel to natural gas, your emissions are significantly better. By some estimates, they reduce their emissions by 90%. And when you add, again, noise benefit and other benefits, and when you add overall fuel operations in terms of cost, that also substantially reduced going from a diesel to a natural gas fleet. All of this while you don't need any major infrastructure other than some of the items that I described.
Yeah, I can see how that would be a huge benefit, especially for an oil and gas company that has all this gas right out there in the field with them. Being able to use it in a gas turbine would be ideal. Probably huge cost savings for them, and a lot less shipping of fuel around from place to place. So great solution. As more renewable energy gets added to the grid, I can imagine that some of these aero-derivatives may be really important as well, being used as peaking units and things like that. Do you think that's going to become a very important part of your business as you see more wind and solar coming online?
Absolutely. The aero-derivative business, going back about 60 years in history, it started as a solution such that it started serving requirements where you covered the peak demand in the summer or in the evenings when everybody go home in New York City, turns their lights on. And again, especially if it's a hot summer, you'll have all the air conditioning and everything coming up. So traditionally, it has been in the peaking business. The word peaking was generally used when the demand crosses, a certain level. What we see with renewables is, I'm going to use a term called reverse peaking. So it's not so much demand-generated requirement, but it is a supply-generated requirement, wherein with solar and wind, as they go away, again, because of the time of the day or because of change in any conditions, as those power drops off, it could not only create a gap in terms of supply of power, which is where we would come in, but it also creates grid resilience and grid stability issues. So we, from an aero-derivative solutions perspective, see this as a key aspect of how we serve our customers. So if you talk about beyond power generation, ancillary services, where you have spinning and non-spinning reserves that helps the grid. PJM was an early pioneer in that area, and what happens is when requested, the generators get paid to have their generation capacity available online. And during this period, the plant is rewarded for having the power on standby, and to be able to get on grid in less than 10 minutes whenever required. And this kind of service is more and more vital as more renewables would flood the grid, which is where aero-derivatives come in terms of supply of power, in terms of ancillary services, and basically providing inertia and reactive power as more and more reasons to incentivize the network to remain online.
All right. Well, Harsh, you've shared a lot of great information about aero-derivatives and the use cases that are available. Is there anything else you'd like to leave the audience with before we wrap up the show?
Well, I would basically just leave the audience with one message, which is as they look at the decarbonization efforts as they look at solutions that would provide grid resilience, resource adequacy, and affordability. We believe the aero-derivative solutions is one of the key things they want to look at. It gives them the speed, the flexibility, and the durability, which are really the hallmarks of what we provide in terms of products, services, and customer support. So I thank you again for giving this opportunity, Aaron, and it's been a pleasure.
All right. Thank you, Harsh. And again, for listeners, that was Harsh Shah, Vice President of Sales and Business Development with Mitsubishi Power Aero. Thanks for being on the show, Harsh, and thanks for listening, everyone.